Okay, we are at Chapter 18, Direct Current Circuits. We're going to learn about resistors, but we're going to start with a short little section on EMF. Now, EMF originally stood for electromotive force. It's not a force, so it's discouraged using that. We just call it EMF. And EMF is what you know as a battery, a power supply. We've been using a power supply. That is our EMF. It's not electromotive force, it's just EMF. Why they don't just call it a battery or a power source, I don't know, but in this book they call it EMF. And we're going to talk about sources of EMF, and you can see they show a battery here. They show it artist rendition of a battery. Well, that looks like a car battery, not like a C-cell or D-cell battery, to a resistor. And so this is schematically what it's like. If you see the dashed line, so you see that script E, that's going to be the symbol for EMF. And you can see the battery has dashed lines around it, and that lowercase r is the internal resistance of the battery. So the battery is actually between terminals A and B. And as the current, as the conventional current exits the positive terminal of the battery, it goes through the external resistor and back to the A terminal, and we'll see that delta V is equal to E, the EMF minus IR, where the little r is the internal resistance of the battery. So if there's no current flowing, if I is equal to 0, then delta V is equal to E, so you get the open circuit voltage. It should be about the same. When you do run current in it, it does drop a little bit just because of the internal resistance. Most of the time we can't measure it, but it does drop a little bit because every source of EMF has some internal resistance. The delta V across the resistor is IR, so the EMF is equal to IR, the voltage across the external resistor, plus IR, it's all one current. The same current runs through the same thing. So it's I times the external resistor and plus I times the internal resistor. So I is equal to the EMF divided by the R plus little r, the external resistance plus the internal resistance. So IE, which is the power, the current times the EMF is the power, and that's equal to I squared big R plus I squared little r. Now, after saying all that, for the remainder of the book, we're not going to work. I think I'm maybe will assign one problem with the internal resistance. Most of the time, we're going to assume that the external resistor is much, much greater than the internal resistor, and so they can be ignored. But you need to be aware that, yes, every source of EMF has some internal resistance. So with that, we'll end this. I think that's it. Yeah, with this, we'll end this section, and we'll go on with talking about resistors in series and parallel.